Hello and welcome to today's webcast, A Business Person's Guide to End-to-End Machine Learning. So my name is Amanda Teschko. A little bit about me. I'm a principal data and analytics consultant with Thorogood. I've been with Thorogood for almost 15 years, helping customers with enterprise analytics strategies and implementations. As for my formal background, I have an MBA from the Wharton School, and I'm completing a Master's of Data Science at UC Berkeley. So the topics of today's webcast, this intersection of business and machine learning, are just areas that are really of great interest to me. And I am joining today's webcast from our Philadelphia office. For those of you who don't know Thorogood, we're an independent global professional services firm specializing in data and analytics strategies, solutions, and services. We're a global company. We have offices in London, New York, Philadelphia, Singapore, Sao Paulo, and Bangalore. And we really offer our customers a full range of data and analytics services. So that includes things like strategies and roadmaps, which we'll be talking a little bit about that sort of thing today, as well as full implementations and developments from requirements through to training and support. You'll see this as I walk through some of our approaches today, but our philosophy at Thorogood is really strongly rooted in ensuring that our solutions are delivered in a way that gives careful consideration to the breadth of technical possibilities, but is really strongly guided by business goals and value delivery. We do work with a number of blue chip customers drawing from a range of sectors. The sectors we most commonly work with are consumer goods, pharma and life sciences, financial services, and insurance. And we are an independent consultancy in that we partner with a range of different technology vendors. And we do partner with the main kind of cloud providers as well as some other more niche players in this space. So I thought I'd start today by talking a little bit about what really inspired this topic. Back in 2020, a study was published by MIT Sloan School with BCG that cited that 71% of companies who had been surveyed really understood how AI could change the way their organization generates business value. But only 11% of those organizations reported really seeing significant financial benefits. And I thought this was a really interesting survey to read. Over the last few years, I've been speaking with a number of our customers and different companies, and I can see that significant investment is being made in this machine learning space, but the operationalization of the results or of the models just really seems to be lacking a bit. So really baking the output of models into decision-making in a way that it has a tangible effect for businesses is really a bit of a challenge and seems to be dampening returns in this space. And so that's really got me thinking a lot about how do we optimize that process to make sure that we're thinking holistically about delivering value, real tangible value with the machine learning or data science solutions that are being experimented with. For the session today, I would say there's a lot that's really been written on why it's crucial for data scientists to really immerse themselves in the business problem to create effective models. And I believe in that wholeheartedly. I think that's super important. But I also think it's just as important that we empower our business people, our decision makers, our stakeholders, so that we can really have richer conversations throughout the machine learning lifecycle that helps us make sure that the decisions we're making throughout are really done in a way that is going to support making the most of the investment that we're making. So this session is likely to be one of a series, but it's really meant to be focused on helping business decision makers build confidence and fluency in the world of machine learning so that we can have more collaborative development and co-creation of these machine learning projects. I'm going to start today with a bit of a layman's explanation of what happens in the end-to-end machine learning implementation. And the intention of this is really to give our business people an awareness of what to expect and an appreciation for what sorts of inputs they could give throughout the process to really help design a successful solution. And I'll try to define things kind of simply here and steer away from jargon. And the approach I'll use with most of it is to look at what is it that we're doing in this phase? Why are we doing it? And then where could our business stakeholders really influence it? Where is your input and your domain knowledge really, really valuable in creating this end-to-end life cycle? And then the second thing I'll do is I'll share a framework that can be used to really help initiate successful machine learning projects by involving and co-creating with business users from the very start. And this focuses on going from this conceptual need, so knowing that there's a business case in which we think we can provide some value, down to an operational plan for how that gets achieved. And the idea behind this framework is that we want to help companies quickly assess the value of different machine learning projects and really shape a road forward for the engagement. So our intentions in this first session are really to just try to help improve that communication between data scientists and business decision makers, to highlight where there are some key points in the machine learning lifecycle where collaboration between business and data scientists will be really useful, and to really help companies move from some of these conceptual ideas to an operational approach for initiating ML projects that do bring together business and technology in the appropriate way. So let's just jump right into it. And I'll start here with, we're going to build this machine lifecycle in pieces, but you've probably seen something like this in the past. And I think the most important question when you're thinking about what happens in the machine learning project is, where does it start and where does it end? And a lot of times what we'll see are some elements in the middle where it might end with a model, or it might end with a machine learning model feeding reports. But I think it's really important to take this holistic view from the beginning of seeing the beginning as that use case definition, and the end is the actual decisions that are being taken. And those decisions might be taken by users, by decision makers. They might be taken by applications in this automated way. But by mapping out the decisions that we are looking to make from the investments made in machine learning, it helps us think holistically about creating success throughout. Now, those decisions may be able to be made on the fly every time the model is run, or those decisions might be longer term decisions, that the model might just inform some things or prompt some thinking that in time we want to change different aspects of the way our business is run. But thinking about the decisions that we want to take from these solutions helps us really think about how we shape the entire project for success. And so what we're going to do is we're going to walk through all of the steps in between that can get us from use case definition to the successful adoption of these decisions being taken. One of the first things that we tend to do in these machine learning projects is to start with something that you'll hear data scientists call EDA, or exploratory data analysis. And what we do in this phase is effectively analysis of the data sets that need to be used, where we'll try to summarize and understand the main characteristics of the data. And we'll usually use different visualization techniques to look at things like distributions or where we're missing data, and some basic querying. So there's not a lot of machine learning that's happening here, just really immersing ourselves in the data to understand how it exists. And there are a couple of key reasons that we do this. First of all, we want to sort of postpone any pre-existing assumptions that we might have about the data so that we can answer questions like, is the data suitable for the model that we're planning to use? How is the data quality? And that might mean, are there a lot of missing values in some fields? Are there null values? What might that mean? Do we see some crazy outliers that we might need to take care of? But also, are there any patterns or any trends that might inform our analysis, that might cause us to think a relationship is happening in the data that we might want to prove through some sort of modeling? And so that's really the intent of the EDA phase. Now, where can the business really get involved in this? I think the stakeholders are going to bring so much domain knowledge to bear that really helping to confirm or reject some of the business assumptions prior to modeling is going to be really important. It can also help us really redefine and enrich the business use cases. So if a data scientist is thinking there's data quality issues, a business stakeholder might be able to say, actually, we wouldn't expect to have values for all of those. So it's sort of okay that we're missing that, or this is what that missing data means, for example. And so by seeing the output of the EDA, by helping to guide the EDA, our business stakeholders can really also get a sense of what exists in the data. And that's a good place for us to sort of start on this shared understanding of what is the source information that we're starting with. Now, after we do some EDA, and I should say just from the start, a lot of these things are very iterative. It's not just a natural one-way flow, but hopefully this gives you a sense of the order that we typically go in before we do some iterations. So after that EDA, then we move into a phase where we talk about data wrangling, or you might hear some people call it data munging or data cleansing or data engineering. But what we're really looking to do here is to transform the data sets that we have and to prepare them for the data modeling aspect. So certain models might require certain structures. They might require that we have no missing data. There may be different requirements based on the sort of model we're going to build. And we need to make sure that the data coming into it is set up in the way that it's expected. We do this because we may need to bring together data from disparate data sources. So this is a place where that can happen. We may need to cleanse that data. As I mentioned, we might need to know how we handle nulls or missing data. We might think about things like imputing data. And what that means is if we are missing data, do we want to make some assumptions about what that data point might be by maybe replacing a missing age value with the median age or the mean age or some other way to infer age from other attributes. We also really look to create a structure here that's going to be suitable for the model development. So how does the data need to look? There are a couple key places here as well where the business can get involved. Thinking about the handling of missing data and that imputation that I was mentioning is something that is really best done, ensuring that we are doing things that are going to be sensible from a business perspective. Because anything we do to impute data in the end is going to have some influence on the model. And so we want to think about how that might affect our results at the end and how we might take decisions based on those results. This is also a great place where our business stakeholders can give some ideas for attribute enrichment. So if I have some attributes in my data about my customers or about my products, there might be a place where we want to cleanse those or make them a little bit more usable. And also prioritization. If we have hundreds or thousands of attributes, not all models can handle that level of granularity. Maybe we might want to think about paring it down to ones that we think will be most useful in the first run of it. And this is a place where we can use some of your domain expertise to really think about where we might want to prioritize some of these different attributes. So the output of this first bit is really to get to a place where we've just kind of got a steady data set that we think is going to be pretty useful for starting the experimentation or the modeling phase of the project. Let's talk about what we mean by that for a second, because I think, it wasn't too long ago I was talking to one of my customers and I kept saying model, and at some point he said, what exactly do we mean when we're saying the model? And I think, I think it's just helpful to align on what that means when we're talking in a machine learning world. So let's think about, I like to use the example of linear regression because I think that is kind of the simplest for most people to understand, and I've had some background in that maybe in algebra or math classes in the past. But let's think about by our data in this example, if we look at our little blue dots on the screen, it may just be some data points relating to variables to one another, right? Something on your x-axis, something on your y-axis. In this instance, we think about the algorithm as being linear regression. So that's a type of algorithm that we'll use. And in this instance, what we're basically doing is trying to fit that line, that red dotted line, to our data. And in doing that, we try to create a model. If you think about a model in terms of linear regression, the model is effectively a formula for a line that represents the relationship we think exists in the data. So in a simple model where we have just one input, one output, and one variable, you can think of the equation y equals mx plus b or plus c, depending on where in the world you learn this equation, where y is your output, x is your input, m is your slope, and b is your intercept. And so you can think very easily about what a model is. Think about your y equals mx plus b line. All it is a representation, some sort of function that is going to turn inputs into some form of output. That output is likely going to be some type of prediction, so maybe yes or no, or predicting a value amount. And then that prediction can normally be evaluated. Was that prediction the same as the actual value? Was it not the same as the actual value when we're looking at historical information? And so this is a pretty simple way of kind of looking at these different components of it. But I think it's important that when we think about a model, we mean this representation of the world that is going to get applied onto our input data to get some form of output data. And so this whole portion of the experimentation is really meant to figure out, what is that model? One of the first things we might ask ourselves is actually, what type of algorithm do we want to use? And this is probably one of the really kind of challenging aspects where your data scientists are really going to be able to help guide you here. But we think, I mentioned linear regression as one. There are a number of different types of algorithms, and this is a place where it can feel a little overwhelming. Something that I like to show at this point is these 9 boxes on the screen. This actually comes from a book called Data Science for Business. I put this source there that I feel like is a really nice entry-level book to data science that really classifies most data science and machine learning algorithms into these 9 different areas. And there's a lot of nuance and depth within each of these, but you can start to think about selecting an algorithm based on the sorts of things you want to do. And I find this summary of it to be pretty useful. I think I'll do some future sessions on this as well. But when you're selecting an algorithm, you're going to think about a couple of things. You're going to think about the input that's coming into it. And something you might hear data scientists talk about a lot here is whether it's supervised or unsupervised. In a supervised learning model, that means we know the answer. So we can feed it historic data and have it predict something, and we can say whether that prediction was correct or incorrect because that label exists. In an unsupervised model, we don't actually know what the right answer is. So we might be looking to say, group customers who kind of seem similar together, but we don't know, there's no physical thing that actually says these customers belong to this group and it was correct that we did it that way. So normally we'll try to think about, do we know the answer in our history or do we not know the answer in our history? And that might influence the algorithm that's selected. We'll also think about the output. So what is the output of the model? What are we trying to predict? Is it a continuous number? Because then we might use regression. Is it a class? So are you somebody who will buy this product, yes or no? Are you in one of these label categories? Those sorts of things. We'll look at more classification type problems. Or you might think about natural groupings, like I just mentioned about the customers. Then you might think about these clustering or unsupervised algorithms. So these are a couple of just simple examples, but these are the sorts of things that data scientists will be doing to sort of try to pair the business question to an appropriate algorithm that takes into account the inputs that we have, but also the sort of output that we want. It's also really prudent here to consider whether we want the output of this model to be very interpretable or something that is just highly predictive as possible. So if I just need to have the right answer, but I don't need to explain to anybody what drove it, then I might choose certain types of models, neural networks, for example, or things that are a little bit harder to see. If I want it to be very interpretable, I might choose a simpler model, something that maybe sacrifices a little bit of predictive power, but gives me the ability to see that, okay, these elements are what's driving somebody to purchase a product or not purchase a product, for example. So these are some of the things that sort of are happening as data scientists are trying to think about this modeling stage and which algorithm to select. The other big thing that happens here is feature engineering. You may hear this. And when we say features, we just mean like attributes about the samples we're looking at. So maybe attributes about the customers or about the products or about the drugs or whatever it is that we are doing this analysis on. And the point of feature engineering is to really take new attributes that we're creating from the data that we have. And the intent of that is to increase the model's performance, to try to make it perform better. Now, there are a number of different ways we can do this. We can think about grouping attributes. So an individual age number might not tell us a lot about somebody's propensity to buy something, but if I bucket them into age groups, we might find that there's a stronger relationship there. We might look at leading or lagging metrics. So for example, the temperature today might not matter, but somebody's propensity to do something might matter on what the temperature was yesterday. So we might think, we want to take some of the information we have, but engineer it in a way that we kind of create a new attribute that didn't naturally exist, but that we can generate from the information that we have. And so this is where the art kind of comes in. We're really trying to improve the model's performance here, and we're really trying to find relationships that just don't exist in those raw attributes. We also might think about adding features here that can aid the model's use in decision making. So if you know that a decision needs certain inputs to be taken, you might want to think about creating features that can be built into the model so that we can see if that's important in the model's outcome. So there's some art here that we can do, not just to improve the performance of the model, but to improve the interpretability of it and the actionability of the insights coming out of it when we talk about the business case. So where can business users really get involved and help kind of steer these things? I think feature engineering is actually a great place to have some input and thought generation from our business stakeholders. First of all, to know what sorts of attributes are going to be really helpful in the decision making. So it might be that the model performs a little bit better if I group ages in one way instead of another. But if I know I have to take decisions within certain age groups, then I might want to structure my data in a way that I sacrifice some predictive power, but it helps me take the business decisions I want to take. And so thinking about guidance in that way is really useful to help steer the data scientists towards how you'll want to use the outputs of this model. That domain knowledge that you have is also very helpful in creating hypotheses about where relationships might be useful to test. So the sorts of features we might try engineering, where we might bring in new information or try to figure out more things about customers to try to improve this model. So I think the feature engineering space is one that would really, really benefit from more collaboration between data scientists and business stakeholders. Once we get to the output of that, hopefully we come to some sort of model that has been tested appropriately, that fits the data well, that is generalizable so that can see when it sees new data, it performs well. And that's the kind of testing and model evaluation phase. Once we get to something that we're very happy with, we have to think about how does this model actually get used? And this is where we'll talk about model deployment and model serving. And what we mean by this is that there was a lot of code that went into getting to that model we're happy with. How do we package that up and deploy it in a way that it can be rerun as new data comes in, that it's very robust and that it's accessible so that the model is kind of hosted somewhere in a way that its functions are available to other systems. And this bit actually requires quite a bit of data engineering and technical understanding to think about how we deploy and serve things as effectively as possible, but also to make sure that we're maintaining the integrity of the model that's been created. This also really used by the reports or the web apps or maybe outputs of flat files that have the results of the model in it. So it's really important for the business users in the sense to give an input into how they want to interact with these models. Should the answers be served immediately where you put information in and you get the answer back right away? Is this just like a forecast that gets incorporated in and it's just another data source to a business user that gets added into existing applications? So really thinking from the beginning about how are these insights going to be surfaced and what is going to be valuable for taking business decisions is going to be really important to thinking holistically about the types of models that we use, how well they have to perform, where they might be able to be hosted, what sorts of things they need to interact with. And so this is another place where it's really good to get a sense of the types of things that we might want to do with the outputs of this model. The last thing I'll say is there's another aspect to this that is really important, and that is the monitoring and maintenance of the model. What this means is we've put this model out there for applications to use, but when do we retrain it? So sometimes we'll get new data. Do we want to retrain it really frequently? Or does the model stay the model for a period of time so that we can see how well it's performing and test back to it? But also we need to monitor it. So is it still accurate? As it's seeing new data, is the accuracy still good? Or have we started to have what we call model drift? And that's when over time, the model that you created stops being relevant for the new data that we're seeing. And so having a really strong monitoring and maintenance practice is really important so that the business users can continue to trust that the model they're using is being watched, that somebody is paying attention to whether or not this model is still delivering good results. Without this component, it's really difficult as a business decision maker to trust that the results we're seeing are correct or should be trusted. A place that's really helpful, so normally this will be handled by some sort of ML ops team or maybe by your IT organization, but where it's really good to have business users get involved are what are the sorts of visualizations that you would want to see to maintain trust in the system. So do you want to see if the system is evaluated on how accurately it predicts something? Do you want to see the accuracy predictions over time? Do you want to see the accuracy broken out by different classes? Maybe it's predicting, the European region really well, but it's not predicting the Asian market as well. And so thinking from the beginning, what will be needed to kind of build and maintain trust, we can put monitoring in place that has visualizations on it that allow you to ensure that that system is continuing to behave in the way that you want it to behave. And then I will say this often kind of causes us to have to go back and do the whole thing over a little bit because we'll get new data. In times, models will need to be changed. We'll get new data. We'll have to go through the process again. And this kind of black box or dotted box I put here on ML ops, I would say, is just the term that's really being used to think about how machine learnings get handled in this operational environment to ensure that everything is working smoothly and that we're retraining as appropriate and that we're keeping the integrity of the model the same. So you'll probably hear that term come up a lot, and it's really critical to make sure it maintains the trust and confidence that you need in the model. Okay, so that was probably a lot. And I think looking at all of that and understanding all those components hopefully is useful. Hopefully you now have a sense of some places where business input can really enhance the model development process, but it might also seem pretty daunting. Is it worth your time? Is it worth the money? And I think the good news is we don't have to spec out the details of all of those things up front. To do that would delay projects too much. But if we can take a quick pulse on how we might approach the end-to-end project from the start, it can really set things off in the right manner. And that was really the idea behind this framework I'm about to share that we've developed, which really thinks about how can we spec out just enough of the case to be able to decide if it's worthy of investment, but not so much that it becomes so burdensome to even evaluate a project before we start experimenting with it. So what can I say here? So I think most people often come to the table with two things, a data source and a business objective. And in some ways, that's a very natural starting point, but it's also pretty conceptual. So they may say, we have some data about sales from a retailer and we want to create customer segments, or we've collected clinical trial information and we want to see if there are any attributes that make someone less likely to respond to a drug. Or in the example I've got on the screen, you might say, we've got a lot of point of sale information, some basket information, pricing information, and we really want to know if, given rising prices, how can we ensure we don't alienate our most cost-conscious consumers? Now, the challenge can sometimes be speccing this out into something that translates this conceptual idea into something that is a bit more operational, so that decisions can really be taken about whether to invest in the development of an end project. Now, I will say in conversations with our customers, many have a list of ideas like this. Sometimes the instinct is, let's just hop right in and start experimenting. Other times there's a bit of paralysis to say, like, we have data, we have a case, but we don't really know what to do with it. And I think in either of those instances, it's best to take just a small step back to very quickly evaluate and put together a bit of an initiation document that gets these projects started on the right foot. So what happens in this framework is we like to think about working from both of these conceptual ends in towards the middle, towards something that gets a little bit more operational. So one of the first things we might do is think about, how do we take that business objective and distill it down into some of the leading hypotheses or success definition? So what sort of evaluation metrics do we need? How well does the model need to perform? But also, what are some of the hypotheses we might try to test? So something like, how do we not alienate this group of consumers is a great question, but what does that actually mean? You can see, now data scientists are trying to figure out the algorithm and the models and the approaches. So we sort of have to go a layer deeper to think about some of these questions or hypotheses or things that we can test. And that might look like, what will a cost-conscious consumer buy product X if given a $1 coupon, for example? And so we try to move from the business objectives to something that starts to distill it down into things that are a little bit more tangible. And then we call it both ends into the middle because on the other side, we want to start building up from our granular data sources as well. So then we want to start thinking about, how do we take the information that we have and process it or enrich it in a way that gives us more information about the business case we're trying to prove? So in this example, we might say, like, okay, a cost-conscious consumer is not a flag in our underlying data set. So what do we have to do to sort of define that cost-conscious consumer? And we might think about, is there more context we can add to, say, the product descriptions? Maybe cost-conscious consumers aren't buying natural products. Well, we might not have a natural product flag. So you start to think about, how do you create more richness in the data and attributes that you have in a way that has the hypotheses you're thinking about in mind. And then eventually you can start to kind of work your way in from those two things to something that becomes more operational, that says something like, what type of problem is it? What are the algorithms we might try? How might we evaluate the performance of it? So you might put in this initiation document, what we're going to try to solve this problem is a binary classification problem. We're going to target an accuracy of 85%. We're going to look at logistic regression, decision trees, and neural nets. And that might be enough to initiate or to start to think about what has to happen to get to some sort of model that will serve some of the business needs. So you might be thinking, how do you do this in practice? And this could be a very lengthy experience that is not necessarily helpful. So what we think is, try to do these things very quickly. We find that oftentimes thinking about including business stakeholders and data scientists or technical stakeholders are really important in these things. Start on your both two conceptual ends where those ones are with just a little bit of pre-work. I think with 10 questions, you can frame both the data sources and the business objective. It doesn't have to be wildly detailed. It just has to get across the context. And then when we move in towards the center, towards the second two, a half-day facilitated workshop between the business and technical teams is really, really helpful to kind of brainstorm and align both on this feature enrichment and engineering, as well as those leading hypotheses. And normally, with just a few conversations, you can start to get some really good ideas and a sense of the types of things that you might want to do. And then it's usually helpful to just go away quickly. And this is probably done more by your data scientist, but to kind of analyze what we've heard and prepare an initiation document for the project. And that document will start to bring in the more operational aspects of it that start to marry the algorithms or approaches we'll take with the business case. The idea is that you can do these things pretty quickly. Sometimes you could do it in a one-day session. You might knock out multiple use cases. The output being just a one-pager that summarizes these things and gives you an opportunity to say, is this a project that we want to get going with? But it's also started the project by already taking into consideration both business and technical aspects to it, which hopefully increases the buy-in that you'll have throughout and the development of it, and the co-creation of these machine learning models with the business really starts to build more trust. Okay, so we are at the end of time today, but just a quick summary. Just understanding the ML lifecycle, I think, can really help business decision makers communicate more effectively with data scientists and data engineers. And there are many points in that lifecycle. Hopefully you saw just a few today that the business input and understanding is critical, is helpful, and really helps build better trust and transparency. Taking a business concept also to a high-level operational plan can really be achieved by working from the data sources and the use case in towards the middle to get to these more operational plans. And we find that these types of initiation documents for end-to-end machine learning projects really set the project up for success, but also make it quicker and easier to be able to get the buy-in to go forward or to not go forward with an ML project. That was a lot that I covered in a short bit of time today. I will just put my contact information up on the screen again. If you have any specific questions about it, or if there are any topics on this track that you would like to hear more about, so thinking about the connection between business cases and machine learning, please feel free to reach out. Thinking of doing this as a bit of a series, so would certainly love some feedback or input on future topics. Thank you so much for your time today, and I look forward to speaking with you.